BGP send updates. Whenever there's a change in the path, whenever there is some tuning done by us to change the path selection, it is very common BGP sending an update. And this update that is sent is okay, legitimate, it is good. You did a change, and because of the change, update goes to other router to update the other router about the changes for the sake of convergence, which is very good. So distributing the routes with latest change is welcomeable. It is good. But the same update can be a problem if it is because of fluctuating link. I repeat, whenever there is a change, updates are sent to update other device about the change. Is it good or bad?
That's good.
Good. But let's say there is a link going down. When the link goes down, there will be a change in the topology. Some routes will withdraw. Earlier it was advertised, now it will be withdrawn. Because the link has failed, you cannot reach the destination.
Right.
So when a link goes down, there is some flash update. Some updates been sent to every neighbor. Again, when the link comes back, again, what will happen? Updates will be sent.
Yes.
It will again go and notify everyone that these changes have occurred now. These are the latest changes. So it is going to send the update whenever there is a link failure, whenever the link gets recovered. Now, these things are okay, good. But what if the link is failing very often? See the problem here. When the link fails very often, the updates also will be sent very often. And BGP is not a small protocol to send a tiny update. BGP sends a big amount of update. Why? It is not only advertising the destinations, the network, it is also advertising the attribute that is attached to those destinations, to those networks, isn't it?
Yes, that's true.
So BGP updates are too heavy for the link to carry. The bandwidth consumption is going to be more. Not only that, the receiving device need to spend a lot of energy, the process, in order to process it. Now, if the link fluctuates very often, then the CPU utilization of all the neighboring router is going to be heavy. Bandwidth utilization of all the neighboring router is going to be heavy. Do you agree in this point?
Yes.
Yes. Sending update is good, but sending update because of a fluctuating link is bad. That link is not steady. It is fluctuating. It's a layer 1 issue. The layer 1 issue impacting layer 2, layer 3 as well. So we need to somehow control this updates that are going to frequently flood and disturb the routers. There should be a control. There is need for a control over this sending of update. That is what BGP dampening. What is BGP dampening? It's a control over sending of update when there is a change. How are you going to control? Updates are good. Why are you going to control it? Yeah, I want to control because I do not want the update to spoil my network. Update is good, but when there is a link failure, very often when one particular link is keep on fluctuating, then it is going to result in a very dangerous network impact. There's going to be a very dangerous impact over the network, which is not really good. I just explained to you what danger it is. It's going to consume all the CPUs of all the neighboring router with new updates, sending and withdrawing, sending and withdrawing. Even the bandwidth is also going to be highly utilized. Now we have to somehow identify such updates, not all updates. I cannot dampen all the updates. Will you dampen updates? No, updates are very good. But we need to identify such update which causes bad impact. We need to identify those updates that is doing bad impact and dampen only those updates. You understand the meaning of dampen now?
Yes.
We are going to suppress only those updates caused because of frequent fluctuation of link. We are not going to dampen normal updates. We need a mechanism to identify those updates that are because of fluctuating link fluctuation, and suppress them, which is also called as what? Dampen them, suppress them. How it is achieved? How this is possible? How do you identify? How do you know how the BGP running on the router knows that this is a good update? This is the update because of fluctuation. How BGP can know it? For that, there is something called penalty. So dampening, what it does, how dampening can identify that there is a fluctuating link, and if I will keep advertising those routes and withdrawing those routes, that's going to cause a bad impact. This is how it is. Whenever there is a fluctuation, it will give the penalty of 1,000. It won't dampen, it won't suppress. Only first time it suppressed, okay? Sorry, I repeat. First time fluctuation happened. There are chances, very rare, there are chances that sometime accidentally someone might pull the wire. It is okay. When they fix it back, then there is no more problem. There is no more fluctuation. For that, it won't do dampening. How? First time fluctuating, it is going to give penalty of 1,000. And then, if the fluctuation didn't happen, fine. Slowly the penalty will get removed. How? Every second the penalty will keep decrementing. The 1,000 will not stay always. Every second it will go to 997, 994, 991. It keeps going down. The penalty will keep going down. But if again fluctuation happen, 1000 will get added to it. So it becomes what? 1991. Okay. Now, so far, how many times the fluctuation happened? 2 times happened. But the frequency was not that immediate. As a result, it didn't reach 2000. 2000 is a suppressed limit. You understand? If the penalty reaches 2000, immediately BGP will stop advertising that. Now, when will it will start advertising? If the penalty goes to 750. When will the penalty go to 750? If there is no fluctuation for a long time, this keeps decrementing and then it will reach 750. Not only that, after every every 15 minutes, whatever the value, say for example, the value is 1500. The penalty got decremented for some time and it reached 15 minutes. When it reached 15 minutes, let's say the penalty is 1500, just for example. It will be much smaller than this. If it reaches 1500, it is going to reduce immediately to 750. Half of it.
Oh, okay.
So this is the trick that BGP uses to identify the fluctuating link. Frequent fluctuating link. Very rarely fluctuating is okay. But frequently fluctuating is what going to have a bad impact. And this is the method, this is the technique that BGP uses to identify. Did you understand the story?
Yes, I understand quite well.
Okay. Now, if a route is suppressed, I told you, if it reaches 2000, if the penalty reaches 2000, it is going to be suppressed. How long? The maximum suppressed limit is 16 minutes only, 1 minute. And then again it will bring it up. When it brings up again, if it goes to this 2000, again it will suppress. So once it is suppressed, it is not going to stay forever suppressed. It keeps coming and checking whether the link got recovered from the frequent fluctuation. And the routes stay good. Even in Cisco iOS, it is supported. Earlier, it was not supported. Earlier, it was supported only on iOS XR and XE, but now it is even supported in iOS. You see, each time a route flaps, a penalty is increased by 1000. When the route exceeds the suppressed limit, what is the suppressed limit? $2,000. Then only the routes get dampened. Once the route is dampened, the route won't install the route into the routing table nor advertise to other BGP neighbor. So the dampened routes will not be there in the local routing table, which has identified that it is frequent fluctuating link. Not only that, it won't even advertise to anyone else. It will keep quiet. When the router learns again about the route with the penalty, the half timer starts. Half-life timer is 15 minutes. When half-life is reached, the penalty is reduced by 50%. So the time it reaches 2000, from there the half-life timer also will start. It will wait for 15 minutes so that whatever the penalty that time, the decremented penalty, it will reduce to half of it.
Half.
So to now retain those suppressed route, it needs to reach the reuse limit. What is the reuse limit?
750.
750. So to install or advertise the route again to the neighbors, the penalty has to go lower than 750. Once the penalty is below 50% of reuse limit, the penalty will be completely removed. So it need not to go to
Right.
zero. If it is half of this reuse limit, somewhere around 350, let's
Mm-hmm.
say, 350 or whatever, it will be immediately gone to zero. So beautiful, right?
Yep.
BGP dampening. Let us go and see this in the action. So we got this 4 routers, and we're going to have only IBGP. Let's not go with eBGP, IBGP. It works in
Yes.
both. So we're going to have only IBGP, and I'm going to use Lubax to form neighbor. Let us do, I have R4, R3, R2, and R1.
All right. Yeah.
Let's start. Notepad. Enable config T interface. Loopback 0 IP address 1 dot IP OSPF1 area 0 interface F1/0 shared IP address 10.123.0.1.255.255.0.0. Then router BGP 10. Neighbor is 3.3.3.3. Remote is 10. Neighbor 2.2.2.2. Remote is,
You're not saying
10.
update source loopback.
Yeah, we need to say that. Neighbor 3.3.3.3. Update source. Loopback 0. Neighbor 2.2.2. Update source. Loopback 0. All right, and I also would like to advertise some networks.
You want this one, this one.
I want to have another.
Wait, loopback. Why not? I just advertise the loopback.
Okay. Okay. Network. 1.1.1.1. Mask. Right. So this goes on
One.
router 1.
That's router 1. Yes. Okay.
On router 2. And this is going to be 2 here.
Wait, look, no.
And
The interface is 00 for F00.
yes.
And
And
this remote AS is going to be 1 that's one
neighbor
neighbor.
is
Update source also going to be 1 that's 1. And then 2 that. And then that look good.
this is on
2.
router 2.
Should come up now. Should see some neighbor. Still, it will come up. I think it'll come up. Which OSPF is coming up.
Let's
So
go to router 3.
So 3 F00. So that will be 3 right there. And the anywhere it's 3, you put 2. And then the network will be 3.
We got another neighbor.
Yes. I got another interface also. F1/0. Ten
10.34.0.4 3.
Do it in class B?
Yeah,
Okay,
you see?
okay.
The above also we use.
Okay. I wasn't paying attention to that.
All right, now let us copy this. Put it on 3. Now 4.
Change. No, just change. No, just change F01, F1/0 to 00. You take that off. And then change it to 00 and put 4 at the end. 4. And then change these down here to take off those 1 and 2. You can, oh yes, advertise, never mind.
Okay, got this. Now, I should be seeing some routes here. Show IP route BGP.
Not yet, maybe.
Let's wait for the convergence.
I'm good.
Show IP BGP summary.
Yeah, good. It's prefix.
Okay, it says,
yeah, it's advertising 1. Go to router 3 and see.
no, wait. It says it is learning a prefix, but it's not showing it. Show IP BGP. Oh, you know why it's not showing? Because OSPF also runs the route.
Yes.
Then we need to do one thing. We need to take another network on all the routes.
Okay.
Interface loopback 11. IP address is 11.11.11.11. 255.245.245.255. Router
BGP10.
BGP10. Network 1.1.1.1.
No, 11.
Mask.
11.
I want to remove
Oh.
this. Network BGP router ID. Okay. Do history.
Show history.
I'd like to copy these things. Enable config T interface 22. BGP router ID is 2.2.2.2. No network 2.2.2.2. This is 22.22.22.22. This is 22.22. This will go.
2.
Likewise, router 3.
Perfect.
Okay. Now we're going to see some
Yes.
routes. Show IP BGP. I'm seeing 33. Locally 44 is advertised. I'm expecting 11 and 22 shortly. Let me go to router 3 and see show IP BGP summary. Come on, show IP BGP summary. I do learn networks, but the problem is route learned from one
Yep.
IBGP should not be given to another IBGP. That
I'm
is what
learning 222
preventing
and 111.
R4 learning and 1 So I'm going to
Like number
reflect the
3, yes.
routes.
Route reflector.
Router BGP 10
Neighbor.
neighbor. Okay,
Should see it now.
clear IP BGP start soft. Now let's go to router 4.
That's it.
Okay, so these three are coming from router 3. These three networks, first three networks, 11, 22. Now what if this link fluctuates? Then there is going to be a flooding of update. Let me see whether I can shut down the switch port console. Okay, is there any way that I can do something bad to this port? Ethernet
Reset.
2.
So it's a reset. So reset down at the
Will
bottom
I
there.
be able to?
And see if it do anything. Oh,
No,
okay,
it will
okay.
reset to the VLAN number. VLAN number 1 is default. What if I set VLAN 10? I'm saying port number 2 is VLAN 10. Is as equal as
Yes.
stopping the update.
Did they take it? Say apply.
VLAN 10.
Say apply. Yes, say apply.
You see. Okay. So now, no, this is also not equal. I want a link failure. So in the real world, it is easy to do. We need to just unplug the wire. But here, not that possible. I don't want to play here, but if any possibility of shutting down this port, I would like to do that. I cannot shut down the port. Okay, now what I'll do is I'll delete the wire. I'll delete the wire. I delete it. So if I go to router 4 now, these routes will vanish and see it's vanished. 11 and 22 gone. And now again I'm going to connect the wire. And in some time it is going to come. First the OSPF should come and then BGP will come. It will come. It has come. Now again if I disconnect, again it will go. Again it will come. Not good. It has come now. It should not come if it is keep on fluctuating. We need to prevent R3 from sending it to R4 and disturbing R4. You understand, no? That's what we are trying to do. See, now I disconnect. Again it will go.
Yes, I
You
was
are
in
in mute, I think. Okay, it is gone. Now, when I connect again, it's going to come again, which I don't like because it's a fluctuating link. It needs to wait for a while. It needs to wait till the fluctuation stops. Keep on sending and withdrawing, it's not okay. See, here it is only two network, 11 and 22. But when you have thousands of network,
resource,
that is a very bad waste of process, resource, bandwidth, everything. So I decided to enable dampening on all the router. In our case, we'll just enable on router 3. The configuration is very simple and one-line command. BGP.
Should it be under the process? Under the BGP process?
Is the command. Router BGP 10, BGP dampening. That's all. I tell you. That's all. Enabling dampening is only this much. If you don't like the default penalty value, then you have an option, you see. You can say what will be the half time. What is the half time? 15 minutes. But if you want to say no, I want every 2 minutes, you can do it. And what is the reuse time? Reuse time is how much? 750, no? Hello. If you don't like that 750, if you want to have 250, then you can do it. What is the suppress value? Default is 2000. If you want to suppress it at 750 also, you can do. What is the maximum duration to be suppressed and stable? It means 1 hour. If you want to reduce that, yeah.
Yes.
Yeah. Okay, I don't want to do those things. The default is good. We have enabled dampening. Show BGP show IP BGP dampening. Dampening status parameters. You see the default parameters. Half time is 15. Suppress penalty is 2000. And the reuse penalty is 750. Suppress time is 60 minutes. Maximum suppress penalty, meaning when you keep on increasing the penalty, 1200 is the 12,000 is the maximum. Decay time, it will go very fast, reducing the penalties. So this is one. Next is dampening flap status. Right now, no flapping, so you don't see anything. Next, is there any path dampened so far? No. No.
So let me ask, it's only
Now
the
let
service
us do
provider
it.
only
I'm
can
going to
enable
cut the
dampening. What
wire.
about the customer? Okay.
Now, anyone can enable this, but this
Okay.
was in service provider track. Now it is also supported in iOS. You can also enable it. Earlier it was not supported in iOS.
Okay.
Anyway, you can enable it. In service provider, it is more useful because millions of routes will be
All
there,
right.
and this will really save a lot of CPUs when there's a fluctuating link. Now, this was one of the CCIE service provider question, exam, lab question, CCIE service provider. Now, I'm going to disconnect the cable.
You didn't have this, you could say suspend.
Cut.
You could say suspend on the cable. Just right click on any one of the cable and you say suspend.
What? It's okay. Now, you see, there is no dampening.
Yes.
Because right now the penalty might have been only 1,000. Yeah, so let us do connect again. I've connected again. The link has come back. There is no dampened path. No flapping status. And
This is back. It came back. This is
now
suspend.
let us
See?
go and
It's
delete
suspended right
again.
there. Let's right click on the link. Do a right click on the link.
Where?
And see suspend down right in the middle right there.
Okay. Now I have suspended. See, in iOS XR and
Right.
XE, there is another command which will show the penalty on the link. 1,000, even 1,000 it will show, but you don't have that command here in this. Okay,
Look
now
at router 4.
why
Look
if
at
I
router 4
suspended,
and
why
see
is
it.
still the
Yes.
neighbor? No,
See, gone
OSPF
down.
should have gone down now. Show IP OSPF neighbor. Okay, now only it has gone down. Okay. Okay, now let us bring it up. Meanwhile, I'll go to router 4 and see. Okay, now I want to show you in router 3 also this command show IP BGP. Look at this. Right now, it is just having it as if it is
Yes.
available. Truth is the link has gone down long back. Now let us
Resume.
bring that suspended link again.
But what I've noticed is that those links are just valid. They're not valid and best. 1 and 2.
Okay, now this
Let me ask
has
a
come
question.
back.
Oh no, never mind, never mind.
Dampening parameters, flapping status, dampening path. No dampening has happened so far. Again, I'm going to suspend.
Let's see. An OSPF goes down. OSPF is still up, so we've got to wait until it goes down. There it is. You're taking forever.
No, the suspend is not really working. Anyway, I'll try. I'll try. I should see penalty now. If it is not,
No penalty. Statistics. Yeah. Just a show BGP dampening and see what happens without the parameters. Just by itself. Oops. It was 3 options.
No.
There are the 3 options there. What was the other option? Okay.
One is simply the default parameters.
Right.
You see, one is simple parameters, the default parameters. The other one is dampen path. The other one
Usually
is
something
flap
there.
status. Not really happening. Actually, you need some better simulator. This is not happening, but I have done in GNS3. I have done this in GNS3.
No, delete. Delete. It's quicker. Clear up the BGP starts off. It's not working too good. Right.
I should see here a small s suspended, and later I should see a small d dampened. That's what I'm looking for. I want to make sure the dampening is enabled. Show run section router BGP. It is enabled.
I don't know why it's not working today. it's not. It's not. Maybe it's the simulator. Maybe it's GNSG. Maybe it's the iOS. Maybe it's just not working today. It's not working today. We just have to maybe 100%. Yes, I do understand it.
But you understood the concept, right? Okay, so you can apply this in the real world, and it will definitely work. Okay, I tell you, it will work. I have seen even in the simulator in GNS3, I have seen it working, but I don't know now.
No, it's not.
Oh, is
It's not.
it? It's not, dampening is not working in this.
Right. Oh,
It should show some penalties and so on. It's not showing.
yes, let's do this.
Maybe I should change this router 3 to some other image. Shall we try that now? So we have changed the router. I'll go to route config, T interface loopback 0, IP address 3.3.3.3.
No, look back, look back.
5
Look back
IP
23. Yeah.
OSPF area 0. And then, wait, let me router BGP 10, BGP router ID 3.3. Otherwise, it will take the biggest one. Interface loopback 1, or interface loopback 33, IP address 33.33.33.33. IPO, no need to run OSPF. Now, interface 500, IP address is 10.123.0.3.255.255.0.0, IP OSPF 1, area 0. Interface F0/1 or shared IP address is 10.34.0.3. IP OSPF 1, area 0.
Neighbor.
Now router BGP 10. Neighbors are 1.1.1.1. Remote AS is 10. Date source. Neighbor 2.2.2.2. Remote AS is 10. Neighbor 4.4.4.4.
I remember it had to be a road reflector client too. Rotor 4 has to be a road reflector client.
Okay. Yeah. BGP dampening enabled. Now show IP BGP dampening flap statistic. Dampening reconfiguration is in process. Okay, looks good. Let's go here and see show IP BGP. I'm able to see 11 and 22. Okay, 33 we have not advertised. Let's advertise. Router BGP 10 network 33, 33, 33, 33 mask.
Check again.
Okay, going back to router 4, I'm able to see 33. Now, dampening is enabled already. Show IP BGP dampening. Show IP BGP dampening. Dampened path, nothing.
Let's delete the link and see.
Status again. Okay,
Let's
it is
delete the
ready.
link.
Parameters, we know already the default parameters. Yeah. What? Okay, let's delete the link. Delete the link. Go to router 3, show IP BGP, and show IP BGP dampening flap state, dampen path, nothing. So let us wait for OSPF to go down. Let us bring the wire back. It is not going to. Anyway, I'll just keep flapping. Go to router
Same thing.
3. I'll bring the wire. I'll delete the wire again. I'll connect the wire again.
No, same thing. No, it's the same thing.
I understand. I can see that.
Okay.
Okay. So this is not happening here.
So you
Let us
shouldn't have
try here,
anything from router 1.
deleting this wire. And see, at least for that one network, something is happening.
Yes.
Router 1, I deleted.
Clear up the BGP stuff up.
I'm looking for the 11, 11, 11. No,
No, but I
clearing
was
is not
talking
a
from
good idea.
row 3
Clearing is not a
perspective.
good idea. That means you are resetting BGP. Oh yeah, there we can do it. I should connect this cable to one source. Okay, we see some impact here. Now let's go again, disconnect the, or I'll go to R1 and I'll shut down that loopback. Interface loopback 11, shut down. So notification will fly from R1 now.
Okay.
R1 will say, hey, that 11 network is no more. Go to router 3. Okay, notification is gone. Okay, now let's go and say no shutdown here. Again, there should be some change, something I'm expecting here. Okay, 11 has come back. Again, I'll go and shut down. I should have done on XR. XR and all immediately it will show. This is even on iOS I have done this.
You know, let me check on my thing later on. I check this when I come home.
Okay, so let's take